Today I'm going to talk with you guys about solving systems of linear equations. A system simply means that we're talking about solving more than one equation at a time. The examples you're going to see have two equations with two variables, an x and a y, and we can graph them, we can solve them without graphs, and I'm going to show you a couple of examples of how you do that. The first thing I want you to know is that these are three examples of what you can get when you graph two different equations. In the first example here, number one, I graphed two lines and they crossed and met in a single point. And this point is pretty easy to identify on a graph. It's the point 1, 3. This is considered to be a one solution system, and the solution is the point 1, 3. The middle example is two equations that are graphed, but notice that the two lines are parallel and they never meet. They do not share any points x, y, and therefore this would be a no solution or zero solution system. The third example has one line drawn, but what you don't see is that both of these equations, when they would be graphed, would form that blue line. Since we're told it's a system and you only see one line, you must understand that this is really two lines and that they share all the points, which makes this an infinite solution system. Some of the points that you could pick out are -2, 4, -1, 0, and 0, -4. You can see them on the graph. So if you need a solution, just pick one of the points that you can see. So we have one solution, no solutions, or infinite solutions. That's the number of solutions. That's all you get. Here are some examples just to practice numbers of solutions. So take a look. How many solutions here? You're right. How many here? Yep. Can you tell me what that number is? 3, -2. You got it. What's this one? None again. Great. All right. As far as the actual solution, sometimes you're asked for how many. In this case, you're asked what is the solution. So now we have to give that point. So look where the two lines meet at the point -1 on the x, -2 on the y. So it's the point -1, -2. Please notice it's written as a point, x, y. This next example crosses the two lines cross at the point -4, 2. So that is our solution. This next one, you can only see one line, but of course it's two, and so we have infinite number of points that the two lines share. This next one, our solution is at the point 3, 2. This next one is at the point 2, -3. And this one, yep, you guessed it, infinite. So when you have a graph, it's really nice to be able to see that the point is part of the two lines. You don't always get that. Sometimes you have just equations and you have to be able to check and see if your answer works. That means that you have to take the x value and put it in for x in your equations, take the y value and put it in for y in your equations. The solution has to work in both of the equations, but the solution then is that point x, y. So I've provided some solutions. I wanted you to see how this worked. You can see it on the graph. I picked a point that I know is on the line. So of course, when I put that point 2, -1 into both of the original equations, which are here, I'm going to get true statements. When I did the same thing over here, when I took this point -4, 1, and I put it into both of the original equations, which are here, of course I got true statements. It's important that you can check it. You won't always have the graph, but when you have a graph, it's pretty easy to see it. Still, it helps if you check, because sometimes you don't use negatives that you're supposed to use, and you can run into trouble there. Here are a couple of more solutions where you can plug the numbers in and make sure it works. I wanted to give you an example down here where sometimes you don't have a graph, and I said that. Before I would go graphing these, I look at the equations. This y equals -2/3 x minus 4 and y equals -2/3 x plus 4 are very similar. They have the same slope. So to me, that means parallel lines. And I don't even have to graph it to know if I have parallel lines, then B is going to be my solution. That there is no solution to this actual system. This next example here, we have a possibility of an infinite number of solutions. It's kind of hard to check that without graphing, so I went ahead and put in the 3, -1. It works. You can see my math here that I got true statements for both of these equations, so therefore that 3, -1 must be my correct answer. I wanted you to be able to see what it would look like when it's wrong, though. I chose the same equations, but now I'm putting in this C answer, -1, -1. So x is -1, y is -1. Do I get a true statement? No. Here, x is -1, y is -1. Do I get a true statement? No. And you can see what ends up happening. -8 is not equal to 12. 0 is not equal to 4. That means that this cannot be the solution. I just wanted you to have an example because everything I showed you up until this point always worked. Sometimes it doesn't. That's it for now.